In this video, I'll demonstrate how to analyze multiplex data using the MyCurveFit Excel Add-In. I have open an Excel spreadsheet containing my plate layout and my raw data. I've gone ahead and performed some formatting in preparation for our data calculations. You can download a copy of this spreadsheet as a template for your own analysis by clicking the below link. You can see on the Analyte 1 sheet, we have the plate layout displaying how my samples are arranged on a 96-well plate, with all my samples run in duplicate. My blank sample is in wells A1 and A2, followed by 7 standards, unknowns 1 through 38, and 2 controls in wells G and H 11 and 12. My raw data has already been populated using links to the Raw Data tab. Opening that tab, you can see here I've pasted in the data from my Luminex Intelliflex CSV data file. One important note, to be able to copy and paste the data into this spreadsheet, my data must be formatted from the Intelliflex in the same format. Sample IDs in column E, analyte name in column H, and the corresponding RP1 median data in column J. Back on the Analyte 1 tab, you'll see I've also included standard concentrations in this table, entered from my kit insert. These concentrations will serve as my calibrator X values. For my assay, a blank correction is performed prior to the standard curve fit. I've added 2 matrices here to house my blank corrected and concentration results. On the Fit Analyte 1 tab, I've created a plot data table and corresponding chart. We'll populate these once we've calculated our fit parameters. And finally, the Sample Table Analyte 1 tab displays the results in a table format as opposed to a matrix format. You can see the raw values have already been populated using cell references to the Analyte 1 sheet. And the blank corrected and concentration columns also contain cell references that will be populated once we've added the data. Back on the Analyte 1 sheet, I'll perform our blank correction. Our blank samples are contained in wells A1 and A2. I'd like to subtract the average of these wells from all others on my plate. So I'll enter the formula by typing equals, selecting the corresponding raw value, and subtracting the average of the blank sample wells. I'll press F4 to make these blank wells an absolute reference, so when we populate the rest of the matrix, the same blank samples will be used. Pressing Enter applies the formula, and now I can hover over the bottom right corner of the cell and fill the rest of the matrix. The blank corrected values will be used as the Y values for my standard curve fit. So I'll go to my standard table and calculate the average of each standard to be used in the 4PL fit equation to calculate my parameters. I'll enter equals and take the average of the corresponding blank corrected wells. So for standard 1, that's B1 and B2. Again, dragging the formula down to fill the remaining standards. Now we can calculate our 4PL fit parameters. I've added a table here to house our results. So I'll select these 4 cells to house my parameters, an additional cell to display the R-squared, and another column to display the headers. I'll type equals and start typing MyCurveFit. For this assay, I'd like to use a 4PL fit, so I'll make that selection from the available options. I'll highlight the X values or concentrations, followed by the Y values or blank corrected data, and press Ctrl-Shift-Enter to apply the formula. Once we've calculated our curve fit parameters, we can now calculate the sample concentrations. The sample concentrations are calculated using the obtained blank corrected RP1 median data or Y values. So we'd like to calculate the corresponding X value. So I'll use the 4PL calcx function to calculate these values. I'll begin by typing equals MyCurveFit and select the 4PL calcx option. I'll highlight the fit parameters and press F4 to make this cell selection an absolute reference. Next, I'll highlight the corresponding Y value and press Enter. Note the selected Y value is not an absolute reference, so it will be updated as we fill the matrix. Now I can hover over the bottom right corner and fill the rest of the matrix. So to this point, we've successfully calculated our blank corrected values as well as our final concentration results. Next, we'll plot our curve. On the Fit Analyte 1 tab, we'll use the MyCurveFit 4PL Calc Y function to calculate the Y values corresponding to the X values I've already entered. For more information on creating your plot data table and charting the resulting fit, please see the associated video. Briefly, I'll enter an equals sign, type MyCurveFit, and select the 4PL Calc Y option. I'll go back to the Analyte 1 tab, highlight the 4 parameters, pressing F4 to denote this selection as an absolute reference, and then select the corresponding X value. Pressing Enter applies the formula. I'll drag down to fill the plot data table and populate the pre-configured chart. So here you can see our data plotted on the chart. Typically, for sigmoidal multiplex curve fits, the data is presented on semi-long axes. So here, the x-axis shows a logarithmic scale. You can specify linear or logarithmic axes by right-clicking on the axis, selecting Format Axis, and toggling the Logarithmic Scale checkbox. Finally, on our Sample Table Analyte 1 tab, you can see because we've already added the cell references, the sample table has been updated to display the results. To demonstrate how to add these cell references, I'll remove the data for Control 2. So let's go ahead and add those references now. Back on the Analyte 1 tab, we can see that Control 2 is contained in wells H11 and H12, or the bottom right cells in our matrices. On the Sample Table tab, I'll press Enter and simply select the corresponding wells in the raw matrix, blank corrected matrix, and concentration matrix. To our sample table, I've also added further calculations, for example, the average concentration and %CV. The concentration times dilution factor column multiplies the entered dilution factors by the calculated average concentration results. So as you can see, we've calculated our results, plotted the fit, and displayed the results in a sample table with some additional calculations performed. I've also configured these same calculations for a second analyte, and you can see the corresponding tabs here. One showing the raw data, blank corrected values, and concentration values, our Fit tab, as well as the Sample Table tab. Looking back at our raw data, we have several columns highlighted in yellow. As I mentioned earlier, the Luminex Intelliflex CSV data file can be copied and pasted directly into this spreadsheet for analysis. The Sample ID column is used to populate our sample table. The analyte name is used to populate the header for the analyte sheets, the header for the sample table, as well as the curve chart title. The RP1 median columns are used to populate the raw data matrices on the Analyte tab. This is the data that we used in additional calculations. So to ensure the data is calculated correctly, the data we're copying and pasting onto this tab needs to follow the same format. I have another data file that follows the same export format. Opening the file, we can see the same data is contained in the same columns: sample ID, analyte name, and median values. To analyze this data set, I'll select the entire sheet, copy, and paste it into our Raw Data tab. Looking at our results, we can see the data has been updated, our chart has been updated, as well as our sample table. If your multiplex assay contains more than 2 analytes, these sheets can be copied and the references updated to calculate the results for further analytes. If you have any questions about how to analyze multiplex data with the MyCurveFit Excel Add-in, please email us at support@myassays.com.